Good evening, scholars. Mr. Spears here. In today's lesson, we are learning how to find the empirical formula of a compound from experimental data. Let's first look at what an empirical formula is. The empirical formula of a compound is the simplest ratio of atoms of each element in the compound. So what does that statement mean? If we take a look here at two compounds, both are made from carbon and hydrogen atoms. We have benzene on the left and ethyne on the right. The formula of benzene is C6H6, but in actuality, this is simply the molecular formula of benzene. For ethyne, the molecular formula is C2H2. Now, in our studies this year, when we've come across a chemical formula, we didn't realize it, but really what we were looking at was the molecular formula for that compound. But some molecular compounds can be reduced to their simplest form to show the ratio of atoms of particular elements in the compound. So for instance, taking both the molecular formulas of benzene and ethyne, if I reduce these molecular formulas, I come to a ratio of 1 carbon for every 1 hydrogen. CH is what is known as the empirical formula. So it is this formula that we're after in today's lesson. I'm going to make a quick note here before we move on that sometimes the empirical formula and molecular formula for a compound are one and the same. It just kind of depends upon what the data gives us. Before I show you how to find the empirical formula, what are some reasons why it might be important? Well, compound analysis such as this is of particular importance in forensics, where you're trying to solve a crime and you've got different substances at a crime scene and you need to identify what those materials are. Then the detectives and the people that form the case can put the different facts and pieces of evidence together to present their cases before the judge. For instance, you can use different analytical techniques to find the percent composition of an unknown substance, as well as its molar mass, and these pieces of information together, you can find both the empirical and molecular formula of the compound. Once you know these pieces of information, then you can quickly figure out what the identity of the compound is. Now, whenever you're asked to find the empirical formula in your chemistry class, remember this simple poem: percent to mass, mass to moles, divide by small, multiply till whole. This poem right here gives you the steps that you need to take to solve empirical formula problems. Let's take a look at our first example. A blue solid is analyzed and found to contain 36.84% nitrogen and 63.16% oxygen. What is the empirical formula of this compound? So in the first step, we're going to change our percents to grams, and this is simply done by taking off the percent sign and replacing it with the unit for gram. In the second step, we are going to take these grams and we're going to change them into moles by dividing by the element's molar mass. And we'll do the same thing for our grams of oxygen. So in our third step, we're going to take each quantity of moles and divide it by the smallest amount of moles. So in this example, that would be 2.630 moles. After dividing by the smallest amount of moles, we're beginning to see the ratio of atoms of nitrogen and oxygen in this compound. But you'll notice that for oxygen, we have a fraction of a number. And so in our fourth and final step is we need to multiply the number of nitrogen atoms and the number of oxygen atoms by the same number until we get the number of oxygen atoms to be a whole number. So we're going to multiply till whole. If I multiply by 1, I'm simply going to get the same number. So if I multiply by 2, I get 2 nitrogens. And when I multiply the number of oxygens by 2, I get 3 oxygens. The number of oxygen atoms is now whole, and all I have left to do is simply write out the formula. So the empirical formula of the compound in this example is N2O3. In example number 2, we are asked to find the empirical formula of a compound that has the following percent composition by mass, and we're given a pie graph to show us the composition of this compound. We see that 85.66% of the compound is carbon and 14.35% of the compound is hydrogen. Alright, so in our first step, we're going to take these percents and change them into grams. Next, we're going to change these grams into moles by dividing by the element's molar mass. And the same for hydrogen. Next, we're going to divide our answer by the smallest amount of moles. In this case, that would be 7.132 moles. At this step in our previous problem, we had to multiply our answers until we had whole numbers. We can see that fourth step is not necessary because our numbers are already whole numbers. So at this point, we can write our answer. Our empirical formula is CH2. In our final example, we are told that a sample of cocaine is analyzed and found to contain 326 grams of carbon, 34 grams of hydrogen, 23 grams of nitrogen, and 104 grams of oxygen. What is the empirical formula of cocaine? Now, the first step in our previous two examples was to change the percents into grams, but we see here that this is already done for us. The amount of each element is already in grams, so we can skip that first step of our poem. So moving to our second step, we are going to convert all of these grams into moles. And depending upon how many elements are in the problem, this might take a little while. But if you're patient, you'll make it to the next step. All right, in our third step, we're going to divide these number of moles by the smallest amount of moles. In this example, that would be 1.6 moles. In our fourth step, we would multiply these answers until we had whole numbers, but we can see we already have that. So the empirical formula of cocaine is C17H21NO4. In these empirical formula problems, sometimes it's difficult for the student to know what to multiply in the fourth step of these problems. This chart right here shows you different decimal values and what you would multiply those by to get a whole number. That concludes today's lesson. For my internet audience, any questions, send to my YouTube channel. For my students in class, write down any questions you may have to share the next time we meet. Thank you for watching and have a great day.